All right, so let's use our calculator to compare these. Those first two graphs, what's the only difference between them?
The second one's shifted.
The second one has the 4 on it, which is going to make it stretched vertically, right? So is that going to affect some of the other features? I don't know. I mean, we can definitely have a look. What's the period on both those tangents? I think that's one you should be able to do in your head. Take pi and you divide by a 4th, so you get
Pi over 4. Would be 8 pi. 8 pi. Oh no, wait.
be 4 pi. Yeah, pi cut into 4 pieces. That's what it is in a 4th. It's going to be 4 pies. Yeah, so flip it if you want to, but so let's have a look. Let's put these in y equals and see what we've got. So here we go. Tangent. There's a quarter. You can write a quarter as 0.25, right? That's the easiest way to enter that one. So let's just compare those two. You want to make sure you have different colors or something so you can tell them apart, okay? Now, zoom options. We're in trigonometry, so usually when we scale these graphs, most of the time, like that one we did a second ago didn't have pi's in it, but most of the time they do, right? In fact, this one, the period you guys said was 4 pi, right? So we should have labels of pi. Which zoom option do you think you should pick if that's so? Yeah. Zoom trig is a good starting point. It's not going to be the only thing you need, but it's a good starting point. So try zoom trig. And there's our familiar tangent shape. It's nice and wide because this guy's got a big period, right? 2 pi each way. And there's the other one. It almost looks like a straight line, doesn't it? It's slightly curved. So this is not a very good window. Let's look at more cycles and also let's make it bigger. Yeah? So let's go look at our window. When you press zoom trig, what's it standardize it to? Let's think about what these numbers are. So it goes up 4 and down 4. What else? What are these?
Mine doesn't look like that.
Are you in radians? Check your mode, guys. If you're in degrees, I don't think we graph things in degrees.
I was in radians.
So you should be in radians. When you look at the window, what is this really close to? 6.15. It's close to 6.28, which is otherwise known as 2 pi. And what's 1.57?
What'd you do, though?
It's stepping by half pies. Okay? So I'll have a look at this with you guys in a second if you need some help. But follow along. Okay, so that's what your window should be. Let's make ours bigger. So I'm going to go out, I don't know, let's go out negative 10 pi each way. So there's 10 pi, 10 pi. Let's step by just 1 pi so we can clearly see the pies. No, let's step by 2 pies. Go step by 2 pies. You really need to experiment with your calculator before you're good at it. And then also, you guys said it was kind of hard to see the steepness of that. Let's go from like negative 10 to 10 just to start out. Give that a shot. Mess around with it. You don't have to do the same thing as me. So there we go. Now it's looking like a repeating tangent. There's the first one. And there is the other one. So I'm going to label this, just remember, because we set this for me to be 10 pi, negative 10 pi. These were going by 2 pi's, right? There's one asymptote. There's the other. There's the first period. We said was going to be 4 pi if we did it by hand, okay? So, do both those graphs look like they fit into the same set of asymptotes? Yeah, they're contained by the same asymptote sets, right? You can clearly see, I think, that it's not straight now, though, can't you? Can't you see that bold line? Is it straight? So, when you try to draw some of these for your homework, if they give you one that says 4 tangent or something like that, what are you going to have to do in the drawing? You want to try to draw it steeper, but you know, it's going to be kind of subjective. So if you want to just point to it and say this one's steeper, that's great too. But a regular tangent, if you draw it correctly, gets flatter toward the origin. And it also depends on what window you have. But if you put something like this in front, it's going to be steeper. Okay, so drawing that's not going to be like super crazy different than the regular one. All right, let's look at x cubed since we're at it. So can you guys remind me, what was the difference between x cubed and a tangent, either one of these tangents from yesterday? So they both have the same kind of shape.
The tangents have asymptotes.
Tangents have asymptotes. They're stuck. They're contained in certain areas, and they repeat. X cubed has a domain of everything. Let's put x cubed in here too and just have a look at it. I want to just do two things at a time so my eyes aren't confused, so I'm going to do that one. And you know, I'm going to make the x cubed bold.
You should get a color calculator.
Yeah, color calculators are fancy. So let's see. There's tangent. There's x cubed. Same kind of shape, right? It just looks like it's steeper again. Or is that the only thing that's different? There's a few differences. Number one, tangent's flatter. And then also, from this picture, from this window, doesn't it look like x cubed is stuck in the asymptotes too?
It does, but you
I thought we said it was infinite domain. You said
can't see it all the way up and down.
you can't see it, so what should we do?
Just make
Go to our window and do what? I don't think we need all this crazy pi. Let's just look at one cycle. We said one cycle was going to be like what? Negative 2 pi to 2 pi, so I'm going to go 3, give us a little extra space. I'm going to scale it by pi this time. And Sean said he wanted to make it bigger, so let's make the y go up to like what? 100? I don't know, experiment. Go by tens. Let's see. Alright. See, now you can really see that that tangent's flatter now with this new window, can't you? Does x cubed look like it's contained by the asymptotes still? Yeah, it's stuck. There's an asymptote. See, I can really see that that's an asymptote now too. See how the tangent really sucks close and tight when you get up to 100 and down to 100. So we've got that. Let's. It still looks like it's stuck in between. Let's make the window even bigger. Now the tangent almost looks perfectly vertical and perfectly flat in the middle. That's the tangent. Look what x cubed did now. Totally busted through the asymptotes, didn't it? It's breaking through that one. It's breaking through that one. I think if you make it bigger, it's going to keep getting more and more wide. Notice, this is key for you guys to understand. Not only did I, like show you how to do some of your homework problems here, give you some ideas for that. Is the machine smart enough to just be like, oh, pick a crazy good window that shows things you want to see? No, you as a human being have to get good at messing with it, experimenting, changing it around to see the true features of graphs. That's key. So that's why I'm saying you got to go through this process of messing around with your graph, fixing it up and trying things. Okay? So now we can clearly see that this is not stuck in those asymptotes, which shows what we thought. X cubed keeps going in both directions, negative infinity to infinity. Okay, so mess around with your calculator.